How to ensure DC-DC converter EMC compliance. Imagine designing a power converter that works perfectly in one device but causes interference in another. That's why electromagnetic compatibility is so important. It's about making sure your DC-DC converter plays nicely with other electronics. When you talk about electromagnetic compatibility, you are referring to how well a device limits electromagnetic emissions and resists external interference. This is especially vital in power systems and renewable energy setups where many devices operate close together. Switching power supplies, like DC-DC converters, naturally generate electromagnetic interference because of their rapid switching actions. To keep your design compliant, start by choosing the right switching devices. Devices with slower switching speeds or those that support soft switching techniques can cut down high-frequency noise. Next, focus on your printed circuit board layout. Keep high-DC/DT currents close to the switching devices and minimize loop areas to reduce radiated emissions. Proper grounding is also key. Use a solid, low-impedance ground plane to prevent ground loops and lower both conducted and radiated noise. Adding input and output filters, such as inductor capacitor or pi filters, can significantly reduce noise traveling along power lines. These filters should be designed to target the specific frequency range of your switching noise. Shielding your converter and physically separating noisy parts from sensitive circuits can also help. When designing for compliance, always refer to standards like CISPR 11, CISPR 32, or military standards such as MIL standard for 6.1. These define limits for emissions and immunity tests. Conduct pre-compliance testing early in development using anechoic chambers or open-area test sites. This helps identify issues before full certification, saving time and money. To improve immunity, incorporate filtering, shielding, and layout techniques that help your converter withstand external electromagnetic disturbances. Using galvanic isolation can prevent noise from coupling between input and output sections. For specific applications like automotive or aerospace, stricter standards such as MIL standard for 6.1 apply. Make sure your converter's input voltage range and load conditions are well tested under different scenarios. Electromagnetic simulation software can be a big help here. It allows you to predict how your design will behave and optimize your layout and filters before building prototypes. Practical tips include keeping high-DC/DT loops small and close to switching devices, using differential and common mode chokes to block noise, and separating sensitive circuits from noisy switching parts. Spread spectrum techniques and soft start features can also help reduce peak emissions. By following these steps, you can ensure your DC-DC converter meets EMC standards, operates reliably, and avoids causing interference with other electronic systems. This careful approach makes your power electronics safer, more dependable, and ready for the market.